All right. Hello, everyone, and welcome back. I hope everyone is doing well tonight. We are going to pick up where we left off last night, plus a couple minor things that I fixed off camera. But before we get into that, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alauzeron, followed by our partners, Griboli's Inc. and Matt Oscar. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a list of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It means a great deal to me, helps me out a lot in covering the costs of running this channel, things like software licenses, hosting fees, and eventually assets, things of that nature. So thank you all very much for that support. I really, really appreciate it. And I would also like to extend a large thank you to all of you guys, the viewers, whether you're joining us here on the YouTube side or the Twitch side live, or if you're just checking out the VOD after the fact. Thank you guys very much for being here. Without you guys, this channel and this project would not exist. So thank you guys very much for that support. Pierto with a 7-stream streak. Awesome. Thank you very much for that. I appreciate you tuning in. Apotham, good to see you as well. I hope you're doing well. Singy and From Lake over on the YouTube side. Good to see you guys. So deserving of a new starting soon image with more contrast. Yeah, actually, I'm wanting to replace that image with something better to sort of show off the new features of the engine. But this doesn't quite cut the mustard for me. So I think we're getting close to the point where maybe I can start putting some artwork, there, but we're not quite there yet. I think once we get the terrain looking pretty good and editable and most importantly savable, I think we'll be in pretty good shape to do things like that. But for now, we're not quite there yet. Doing pretty good. Apotham, I am doing well. Thank you for asking. I'm super happy with the way that things are coming with this engine. Finally getting some really big visual updates. I wanted to just kind of talk a little bit more about what I had in mind for the zone transitions last night. So what I basically had in mind, and I didn't have the materials set up to show this properly last time, but basically what I wanted was the ability to sort of seamlessly transition from one zone to the next. So let's see, we've got this, sort of paver path material here. And so you might have this, running all the way back to a base or whatever, right? And so when you get ready to switch zones, I wanted the ability to be able to switch something like this particular road, right? And so within a particular chunk, you might be able to actually switch materials to something like this, where you have like a different road, right? And so if we actually shrink this down a little bit, I wanted the ability to sort of be able to mix the two of them as you sort of transition from one zone to the next. So we have the ability now to sort of paint this, and we can very easily just, sort of drop a brick here and there, just to sort of have a little bit smoother of a transition from one zone to the next. And what this allows is us to sort of switch tile sets within a reasonable radius, right? So by the time we actually get to, the other side of this, we might have a much better setup for, this sort of square paver road versus the sort of more natural stone looking thing that comes from over here, right? And so the idea is that we have sort of these transition chunks that we use to sort of, extend the transition materials out in both directions, right? So we set materials there, and we just sort of paint these in a little at a time, and sort of just kind of create little gaps and breaking up between the two to sort of balance them out and make a semi like natural looking sort of transition between the two, right? And so we have the ability to do that, and that was really what I was wanting to showcase in the previous stream, but I didn't have it quite set up yet to do that. I've also, as you might have been able to tell, I've also been able to work out the issues with painting in terms of actually transitioning between materials correctly. So, material index, let's go back to 0. So now I have the ability to sort of blend these materials together, and it looks a lot more natural, and all of the sort of artifacts that we had in the last scene, or the last stream rather, are all gone. So, it kind of allows me to paint things a lot more naturally, where I can just sort of paint a little bit at a time and sort of have a gradient instead of, just harsh edges everywhere, right? So I could sort of have that all underwater there, and sort of have a little bit of a gradient along the coastline there. And so that, I think, looks a lot better, right? And of course, we can't save this yet. We're not quite there yet. And I do eventually need to make some modifications to materials, but let's say like I've made a mistake here, right? Where this is a little bit too strong. I went ahead and added this erase in, and all that does is take the strength and set it to negative. So that essentially backs out the material at that particular index, right? So it allows me to sort of come back in here and say, well, I want to actually push this dirt back a little bit. And maybe, change this to a smaller diameter and come in here and say, well, maybe I only wanted that portion to look like that, right? And so now we have a lot more fine-grained control over how this stuff is actually painted. And it's going to allow for us to make a lot more sort of natural-looking terrains and whatnot, right? So obviously we need to do some other things, like we need to eventually create some different brushes that sort of randomize this a little bit. But at least for now, this is kind of a pretty good start in terms of where we want to actually go, right? So I can actually come in here and I can actually add some dirt into the middle of the road just to make it look a little bit more natural, things like that, right? So that's kind of where what I was wanting to show in the previous stream, but we didn't quite have it there yet. And so I've made a few changes offline, nothing too crazy, but that's kind of where we wound up. I also made a couple of tweaks to lighting and the terrain and the shadow maps, and actually fixed some issues around that, so that those actually show up correctly now as well, including for point lights and things like that. So those actually look a lot better now than they did in the previous stream as well. Let's see, and I think that might actually be it for now. So what I'm hoping to tackle tonight is actually elevation. Because, having this sort of sine wave pattern in here is cool and all, but it's not really obviously what we want in a terrain in the end. So we're going to look at actually creating some tools around changing elevation of the terrain, and we're going to see how that works, right? So we're gonna attempt that tonight. That is what is on the roster. Let's see. Got this question burning all day. How are you thinking about undo redo for the editor command pattern with the reversible actions or another approach? Actually, that's exactly what I'm thinking, is just command pattern with reversible actions. I haven't put it in yet just because I haven't really needed it, but at some point we are going to need it. And the one thing I'm thinking about undo redo is each one of the respective editors is going to have their own undo redo stack. So whatever mode you're in, and even the sub mode within that may have its own undo redo stack. And I want to keep those things separate because generally speaking, they are separate things. I don't want to sort of have to bounce around between editors and undoing actions. That way that can get very messy very quickly. So that's my idea there. Musta, good to see you as well over there on the YouTube side. Let's see, is decal the technique you use to paint on the terrain? No, it is not. So we actually have a list of terrain materials, and we essentially blend between those things using a splat map, which uses the RGB and A channels of a image or a texture to blend between those. And we also have some logic in here to, as you paint, it sort of also suppresses the other layers so that we get that nice smooth blending effect between all of the layers. And so we do that, and it's working pretty well, I have to say. I'm pretty happy with the results. But yeah, we don't have actually decals yet. At some point, we need to implement that. That might actually help with visualizing like our terrain tools and whatnot while we're painting, but we don't have that in the engine yet. So let's see. Apotham is on a 10 stream streak. That's awesome. Appreciate that. And Pale Blue Zebra is also on a 10 stream streak. Very much appreciated. Thank you both for that. Good to see you. Good evening to you as well. Okay, so here's what I'm thinking. We have this HF terrain do elevation, and this is tied in to, let's see, where was that? I think it was down here. Right here. So whenever we do a mouse drag, we essentially perform a raycast into the terrain that returns to us a position and a normal, what block it came from and what chunk it came from. And so we have that same data available for elevation. So for an elevation mode, that is what we can expect. So we already have all of that information here. And I just kind of copy pasted a little bit of code here from the terrain paint mode. So this is basically where we're starting, is from the ground up on this feature. I've got the hooks in place, but nothing more essentially. So U and V were actually texture coordinates or texel coordinates for painting. So we actually don't need those. What we have here is, let me see, wait a minute, let me make sure. I don't think we're going to need those. So local X and local Z are the offset into the particular chunk from, or no, that's actually block offset. We should probably change that to chunk. Yeah, we should probably change that to chunk. And so the idea is that we essentially need to get the closest vertex to wherever we clicked. And at least in initially, we're going to just add height to it, right? We're going to have a few different modes where we say add height, subtract height, set height to a particular level where you have a text box in. And then we'll also at some point be able to define some sort of brush so that we can actually have a brush size and a fall off for that, so we can actually raise things up to make hills and valleys and things like that. But we need to start at the simplest point, which is essentially a vertex. So I'm going to do this the naive and stupid way. So if we take a look at chunk, and let's see, we have vertex offset and vertex buffer offset. So vertex offset is how many elements into the vertex array we are starting with. So this is going to be, I think, a U32. Yeah. So we're going to do a for U32. And we're going to set this to I equals chunk vertex offset. Actually, maybe we should do... Maybe we should offset that within the for loop, right? So we'll just say within the chunk, we're going to say chunk HF terrain chunk. Do we have stride in here somewhere? I thought we did. Let's see. Oops. Let's see. So we need HF vertex stride. Okay, so actually I'm not 100% sure that's what we need. I think we actually need a chunk quad count +1, so that's in one dimension. Do we actually have chunk vertex count? That's what we need. So we want to iterate over all of the vertices, right? So we're going to say I equals 0, I is less than chunk vertex count, and like I said, we're doing this the stupid brute force way for now, and we'll figure that out after the fact. Whoops. There we go. All right, so what we're going to do is we're going to say HF terrain vertex. Or is it HF vertex? Why are my types not showing? Don't we actually have, yeah, HF vertex 3D. All right, so we'll paste that, and we'll say, do I want a copy of it or a pointer to it? Take a pointer to it. So we'll say equal to, we actually have the block and the chunk, but we don't have the terrain. That's problematic, because that's where the vertex array is. And I don't think, yeah, the block doesn't have a pointer to its terrain. Maybe it should. All right, let's just sort of pseudocode this, right? We're going to say T vertices, and then that's going to be sub chunk vertex offset. Right? That is essentially going to be, we're going to check each vertex and see which vertex is actually the closest. And then at some point, we will go ahead and modify the Y. The Y element of the position of that particular vertex. And for now, we're just going to increase that, right? Are you planning to use dear I'm GUI for your GUI? No, we've written one from scratch, and we're using that. Let's see. Singing YouTube would probably beat everyone's stream streak if YouTube had it. That's probably true, yeah. Will Kohi 0.12 include features such as skeletal animation, GUI, edit mode, terrain paint, etc. that you implemented recently with an update of testbed KApp? Yes, actually 0.11 contains most of that minus the terrain stuff. So 0.12 is going to contain everything that we're doing now with terrain stuff and whatnot. So, yes. Okay. So, I need a pointer to the terrain. So, thankfully, actually, we have where we're hooking this up. We have, I think we have the editor state. So let's see, sender. Yeah, editor state here. So we can actually send the terrain. So we're actually going to need to do that. And I'm actually going to hook this up to both of these functions. So wait a minute. Actually, editor state is there. We might already be in business, actually. We already have editor state. Yeah. So let's see. Editor state. State, actually, it's just state. And we want href terrain. Wait a minute. Edit scene. We don't have a way to retrieve that, do we? I don't think we do. Because the editor doesn't necessarily know how to retrieve that. Do I want to expose that at this level? I think that's fine. All right, so what we'll have to do is make a small modification to casein. Let's see. So we have already href terrain render data. And we have a raycast function. But we don't actually have a way to retrieve the terrain itself. So let's go ahead, I guess, and do that. I'm not going to make it const. So we're going to say kscene href terrain get. And all we need is the struct kscene scene. And it's just going to return a pointer to it, which is simple enough. So I think that's all we need. If we need anything more fancy, we can address it when needed. So return the address of scene. HF. Right. Okay, so we can do let's do HF terrain. Equals K scene get HF terrain. What did I call it? HF terrain get. There we go. And so we want states edit scene. Right, and now here we can actually just do terrain vertices, right? So vertices aren't really that big. I suppose we could work with a copy of this, but I think I want the index. So I guess let's do a vec3d, vec3 distance, and we could use distance squared. And we'll do, you know what? Let's actually not take a pointer of this. We'll just take a copy of it. That's fine. So we're going to use v. And then the point that we're going to use is going to be, so we have local x and local z. Actually, wait, no. Actually, what we want is just position. So we want v position, but that's a vec4, so we need to do vec3 from vec4 on that. And there we go. Okay. So f32 dist equals that. And I think what we're going to do is we're going to say f32 shortest dist equals, and we're going to set this to some absurdly high value, right? And what we'll do is say if dist is less than shortest dist, then we're essentially going to cache that particular vertex, right? So we're going to say that we want u32 index equals invalid ID u32, and we'll do a, I guess we can do a HF vertex 3D vert. Right, and we'll just leave that as is. Actually, I guess we could probably zero it out. And so if we have something that is the shortest distance, then we're going to say shortest distance equals dist, and then index equals I, and then vert equals v dot position, or just v rather. All right, so this should get us the closest vertex. Now granted, this is brute forced, right? So let's put let's actually put in here, fix me, optimize this, right? We're just doing it brute force for now, get it to work, and then we can optimize it later. So we essentially search all the vertices within the particular chunk, which is only 256. So like looping through that is not going to be a huge deal. At the end here, we'll have our closest vertex. Then what we'll want to do, is we'll want to do, we'll want to say vert position.y plus equals, I don't know, some amount, 0.1 f, right? That's probably way too much, but there we are. So we're basically just going to hard code that for now. We'll work in our tooling and options afterwards. We just kind of want to get this to work. And then what we need to do is we then need to copy this back to the vertex array of the particular chunk, right? So we need to do, let's see, terrain vertices, and then we're going to say sub, and then we have the index already, index dot position. Actually, I guess we could just do this, right? We don't even really need that, I guess, for now. Yeah, that should be fine. So we go ahead and increase that. We should probably check to make sure that, index was actually set, even though that we know it's going to be, because this distance is ridiculous. We go ahead and set that, and then we just need to do a update on the vertex buffer. So let's see. We have in here somewhere vertex update, render geometry vertex update. We could just do what that does under the hood. So let's go ahead and just grab that and pasta it here. So render system state. Let's see. Okay, apparently we don't have that. Why not? Render system state. Maybe we need let's see. Why do we not have... Maybe we need the renderer front end. Really? We're in our front. Oh, because it's private. That's why. Okay. So I think what we really need here is a struct tag. Okay. Let's see. So load the data, vertex element size. Let's have a look at what this function expects. I'm actually going to close this other buffer real quick. So load range expects the buffer, obviously. Standard vertex buffer. We'll have to get that. Expects the system state. Let's actually do... Let's rename that. Okay, so vertex buffer offset plus offset. So what we're actually going to need here is this is the offset into the actual vertex buffer itself. Although before we get that, I suppose we actually need this. Right, so let's actually just go ahead and do that. We're going to do render state, and we're going to do, let's see. Render buffer. K render buffer, that's what it was. So K render buffer, vertex buffer equals that, right? And now we have vertex buffer. Okay, so vertex buffer offset, that's going to be terrain vertex buffer, base vertex buffer offset. And then plus the offset. So the offset is actually going to be the index times the size of HF vertex 3D. Let me just make sure. This doesn't seem right. Hold on. So vertices chunk vertex offset plus I is what that should be. Right, so this is going to be replacing offset, and this is going to be index, and we're going to take this whole bit and multiply it by the size of a HF terrain vertex, HF vertex 3D. There we go. All right. Let's see the size. So that's the offset. The size is going to be let's see, element size times vertex count. So we're only going to modify one vertex here, right? So we're just going to say size of HF vertex 3D. So that's that one. And then load range next is the data. And then whether or not we want to include it in the framework load. So the data that we're going to upload is just going to be the single vertex for now. So we're actually just going to grab the address of this. Right, so that's going to be that. And include in framework, we're going to say is false. We don't want to include that in the framework, in the render frame workload, at least for now. That may change. Okay, so we set a single vertex. We add, we grab a single vertex, rather. We add to its y coordinate, and then we set it back into the array, and we update that render buffer. I don't know if this is going to work. That seems right to me on the surface, but let's see. Unused local X and local Z. Yeah, that's not surprising. I think there was one more in there too. Variable vert set but not used. Okay. Let's just comment this out for now. Okay. So let's go ahead and run this. We'll see if this winds up working. I don't know that it's correct. True Nemesis UK, how's it going? First time chatter, welcome. I hope you're doing well. Okay, so we're going to go to HF terrain mode and we're going to go to elevation and see what happens. Aha! It worked. How's that for a first time try? Not bad. Is it perfect? Hell no. Look at that. That's awesome, right? But okay, it looks like once we get outside that chunk, it's a little foobar. And we have some splits at the chunk border, which I'm not surprised about. I knew that was going to happen. I knew that was going to be an issue. Why is that one all the way like shooting in the distance though? Okay, so we obviously have some issues, right? But for a first time attempt, that is not bad. I'm pretty happy with that actually. Okay, so it looks like we've got some work to do around. Why is it? It looks like it's modifying more than just the y-axis. So we're gonna have to check that out. Okay, and I have a feeling that is due to, yeah, see, it's actually modifying it outside of the first chunk. Okay. That actually works better than I thought it was going to initially. Okay, so let's think about this for a second. Why would it only work in the first chunk? Probably because, let's see, chunk vertex offset +1. Let's take a look. Actually, I'm going to split this and go to HF terrain C. And where we're generating the chunk, I put a vertex offset in here. And so this is supposed to be an array offset, right? This is the offset into the vertex buffer. This is the offset into the vertex array. So I'm actually just wondering if I used the wrong thing there. So we have terrain. Actually, yeah, I think we're probably doing a couple things wrong here. So let me actually space this down so it's not scrolling off the side of the screen, because that's really annoying. Okay. Let's see. Okay. Thank you for the follow, by the way. Appreciate that. Let's see, in 3D game dev industry, is everyone using the same metric that 1.0 in world space is equal to 1 meter in the real world? No, not necessarily. So that can vary greatly per game and per engine. That is what I'm using because it makes the most sense. But games like WoW, for example, do everything in yards, right? And they actually have like I don't remember what the exact scale is, but they actually have like certain number of units equals a yard. So it's not necessarily always a meter. I just think that 1 unit in the world equaling a meter is the simplest way to go. So that's what I've chosen to do. I've seen some engines before, or some programs where you can actually set that. And I've seen some that use imperial units. I've seen some that use metric units of different scales, like centimeters and stuff like that too. Really depends on the context of the game itself. All right. So we're dealing with a single vertex here. I can get rid of this poop because I know that's not necessarily a problem. So we find the closest vertex to where we've clicked. I think this is fine. It goes ahead and grabs the index and the shortest distance there, and then sets, let's see, terrain vertices index. So index is based off of I. which is the, that's part of the problem right there. So index actually needs to be chunk index times HF chunk vertex count plus I. Right, and we'll put brackets around this just to make sure that that's one problem. Let me actually build that and test it real quick. But I suspect that is the reason that we were constrained to just that one particular block initially. So if we go here, and I'm actually going to start over this way. Let's see, in elevation mode. Okay. It's obviously like blowing out the Y vertex like way, way, way too strong for some reason. It doesn't do that on this first terrain block though. But over here, it's just absolutely going bonkers. Let me think about that for a second. So why would that be? So index is chunk index times chunk vertex count. That should be both axes, right? Yes. So each chunk has 89 vertices. So we get that based off of the chunk index itself. So I feel like that is correct, because even when we are clicking on the sort of second chunk there, the vertex that we were editing lined up with that. This, though, seemed like it was wrong. And or the position into the array is wrong, which is, I'm thinking, maybe more likely. So let's see. So the index, let's just treat it as a array of HF vertex 3Ds. So the chunk vertex offset, is the chunk vertex offset actually taking into account the block? It is. So chunk offset here should essentially be an index into the array, because we don't take size into account until at the very end here. Vertex buffer offset, chunk offset times size. Okay. Are we actually, should we be using the size of? Let me think about that for a second. I don't actually think we should be. I think that might be part of the problem. So chunk vertex index, or vertex offset plus index. The vertex offset is the offset into the array plus the base vertex offset. So when we load range, the offset is the offset in bytes into the vertex buffer. So actually, I think this might be correct. Oh, wait a minute. Chunk vertex offset. This addition needs to happen first before that multiplication. That might be the problem. Valve uses inches in their editor, if I recall correctly. That might be correct. I think that might be one of the ones I'm thinking of, although I haven't looked at it in years, so. But I think you might be right about that. Okay. So these are fine. What about these? Okay, why is it grabbing? It looks like it's grabbed the neighboring geometry there. It has. What the heck? Okay. So it's fine here. But as soon as we go outside of that, it's foobar. Okay, so I wonder actually. So we get position. Oh, the position I think is local to the particular chunk. That might be the problem. I think the position is local to the chunk. I don't think it's global. I suppose I could verify that really quickly, but if I think about it that way, so the position, vertex position, so if I offset the position by the chunk's position, I don't think I actually have that, do I? I do have that. AABB, I could use min for that. So let's do vec3. Actually, we could just say position equals vec3 add. And we can do position and then the minimum of the AABB. And that should give us the, or is that, that would work if position is global. I should probably output what position is, actually. Let's see, k info. Well, I'll put this function name and then I'll do position equals, and I'll output a vector3 with 3 decimals of precision. And I'll use function and position, address of position. See what the log spits out for that. Because I actually wonder, I don't remember off the top of my head now if that position was global or local. So adding it may not actually be the answer. So let's move this over here. And elevation. Okay, so that could be global. Yeah, that looks like a global position to me. Yeah, that's a global position. Okay. So all of the vertices for the terrain are all going to be global positions too. So I don't actually need to do this. That's actually going to foobar more things and it's going to help. Let's see. So if position is global, then we use that to get the distance between the vertex and that global position. So this actually, again, should be correct. What am I missing here? So we say that the index is the chunk index times the vertex count. So that's the index into the vertex array. Chunk index times... Right, so how many chunks were into the array? Oh, you know what? We don't have block index either taken into account, which is going to be a problem on later blocks. So this actually needs to also take into account block. Block index times HF block do we not have vertex count for blocks? Yeah, we do. Okay. And then plus that, right? So our total vertex array, we need to offset by what block we're in, then by what chunk we're in, then to the particular vertex within that particular chunk. Terrain vertices. Okay, so chunk vertex offset plus I. But chunk vertex offset is taking into account the block offset. Okay, so I think this is still correct. Okay. Position Y. So we know this works on the very first one. What would cause that to foobar on the next chunk up? I think it's going to be something like an off by one issue. Let's see. Bimtron, how's it going? What's up? How long have you been programming in C? I switched from C++ to C about 5 years ago. 5.5 years ago. So I always used C like C++, and I did that for a number of years. So I guess you could maybe kind of, sort of, but not tack that on. So I guess you could say 5 years. Penguin Operator, good to see you. Lurking, sleeping, fair enough. All right. I still think that there's something wrong in here. It's a chunk vertex offset. Oh, wait a minute. Base chunk vertex offset. No, this should probably be... I wonder if this should be vertex offset, vertex buffer offset. Oh, let me think about this. So base vertex buffer offset plus chunk offset times size of. Oh, wait a minute. Are we kind of doing the same thing? Chunk offset is literally that times The problem is I don't know if this is wrong or this is wrong. Just thinking about it critically here for a second, I feel like this might actually be the problem. So terrain vertices index, that's vertex. Okay, so load range. I guess actually, technically speaking, let's see, we have the state, the buffer, the offset. So this is what we're calculating as the offset. Offset in bytes from the beginning of the buffer. Size of the data to be loaded is just going to be size, right? Which is this. And then the data to be loaded. So actually, I kind of feel like we should probably do. Well, we need to do two things. Because if we don't update the terrain's vertex array, and we just pass like V into here, that's going to be wrong because we're not going to be able to accumulate the Y changes. Speaking of which, I probably ought to reduce this a little bit so that it doesn't grow quite so fast. So the offset is the bytes from the beginning of the buffer. So if I were to use the buffer offset, and then multiply, let's see, the index is, no, that's an index into that full array, actually. So, do I actually even need this? I'm kind of thinking not. Because index already kind of has that. So if I get rid of this, Frozen Shadow, how's it going? Good to see you. Hope you're doing well. All right, let's run this one. For a turn-based chess game, should I use async IO stuff? Sounds overcomplicated to me. I doubt it, to be completely honest. Go with simple, go with what works first, and then if you need that level of complication, add it. Okay, so that seems to work fine there. What happens when we go over here? Aha. I think I might have gotten it. Okay, we still do have tears between the blocks, but that's a solvable issue. Look at that. We can actually modify the height of our terrain now. Complete with shadow mapping, which I added, by the way. Off camera, I forgot to mention that. But we can actually edit the vertices of our terrain, which is friggin' awesome, I think. So being able to do that and being able to paint is pretty sweet. Okay, so how do we handle these terrain tears, right? Because that's not great, right? Because we can paint them individually, which is obviously not what we want to happen. So we don't want those tears. So what we have to do is we have to determine if we are on the border of a chunk. And if we are, then we need to get the next chunk in that particular direction and also modify its vertex in the respective location, which is easy enough to go, either north or east or west, right? But the part that's going to get complicated is this situation that we have here, where we join 4 of them, right? That is going to be interesting to figure out. One more thing I do want to check really quickly is I actually placed a tree where our 4 blocks actually meet. So I have a land marker so I can actually test stuff over here. So you can see there's the seam right there between the different blocks and the chunks. I just want to test to make sure that that actually does what it's supposed to. Okay, so that's actually pretty consistent, which is good. So, okay. So that's not wholly unexpected. All right. Let me think. Okay, so if we're going to have to check for boundaries of... We're going to have to check for boundaries of the chunks and then get the chunk adjacent to it, which I actually started already kind of writing the code for this, but it's completely untested, so I have no idea if it's going to work. I suppose what we could do is, instead of actually getting the chunk and all of that stuff, we could probably try to figure out the offset of that. Based on the direction we need to go. So I suppose we could figure that out like one at a time, right? So I happen to know that the terrain is built going this way, from right to left as the screen is oriented now. So that's probably going to be the first version, or the first direction I'm going to check. Because I think that'll be the easiest. So, all right. So we have this. Let's see. So we are doing this by index into the vertices. I think we need to modify this slightly to make it a little bit easier. Well, I suppose we could actually extract the X and Y, or the X and Z from this. So I think, let's see. Let's do U32, or I guess we could do Yeah, U32 is fine. So we're going to say X equals, or let's do Z first. We're going to do I divided by HF chunk. Wait, not chunk vertex count. Don't we have chunk vertex stride? What's it called? Let's see. HF vertex stride. That's what I wanted. Oops. Right, so we'll get the Z by taking the current index and dividing it by the number of columns that we have. And then it'll give us that. And then we can take the U32X and we'll take I and we'll mod it by HF vertex stride. And that should give us the X coordinate. And actually, before I do anything with that, I just want to verify that that is going to be correct. So I'm going to do a ktrace XZ, and then we'll just do a %U / %U and do X. Oops. XZ. Oops, X, then Z. There we go. Okay. So this should give us the local X and Z in the console. If I can get it to quit. Yeah, it doesn't see. Oh, you know what? It's iterating, so. Right. Put it in the wrong location. I want this. Let me think about this. This needs to go down here. And this needs to be index. That way we don't get every single iteration of it. There we go. 0, 0, 1, 0, 2, 0, 4, 0. Okay. All right. So that all makes sense, right? We can do this. That's fine. Then we have 7, 1, and then it should. Right. So see how we have a 0 there, and then we have an 8, 1, and then a 0, 10. Why is that 0, 10? Let me think about that for a second. Did I do this right? So we have 0 through 8, and then it jumps to 10. Right, so I'm gonna bump this one up just to kind of give me a visual difference here. Right. What's this one? 0, 9. Oh, this one's 0, 10. This one's 1, 9. Oh, I see. I was hitting the next vertex row. I see what was happening. Okay. So 0, 9. Okay, so that does work. Okay. So I do have it correct. So essentially, if I'm adjusting if x is 0 or x is 8, then I need to essentially reach over to either forward or backward to get the next index in line, or the next vertex in line. Okay. So let's see. Because technically we're going to have to do, I guess, 2 of these things then, and if that's the case, right? So how do I want to do this? So I guess we should probably split this bit into a different function, and then we can call it multiple times if need to be. So let's do that. I'm just going to put it right here for now. HF terrain adjust vertex, sure. Adjust vertex at. Right, and I'll just add what I kind of need here. So we need terrain. So I'm just going to do HF terrain, terrain, and then U32 index. Is that it? I think it is. All right, so here we can just do a call to this guy. And we can just do terrain and index. Right, so that's the normal use case. And then if we have, so we'll say if x equals 8, or I guess we should probably say HF let me think, quad count. Nope, that's not the one I want. Block quad count. Chunk quad count. So if that's equal to chunk quad count, then that means that we need to reach backwards. Actually, let's do Z first. Let's do Z first, because Z's easier. So we can make a second call to this, and because it's along the Z axis, I believe we can actually just do index -1. Right? And then else if Z equals, let's see, wait a minute. So, no, if it's this, it needs to go forward. Otherwise, if Z equals 0, then we need to go backward 1. Whoops. However, there are caveats to this. So we need to also check, are we at either end of the terrain? And this is only going to work within a particular block. Let me test this first. Make sure the concept is right, and then we'll go from there. Because there's going to be things we have to take into account for block borders as well, right? So I'm not going to do this at the 0 index here, right? So that's index 5, 7, 8. Oh, damn, there's still a tear there. That didn't work. Okay, why didn't that work? Oh, it should have been X, not Z, I guess, in this case. How did I get that backwards? Okay, so let's try this one more time. Oops. Elevation, not paint. Okay. So that's 7. Nope, that's still split. It should be. It's kind of poking through, which is actually kind of funny. Doesn't seem to want to do it from either side. Nothing hit, that's interesting. Oh, are we actually updating the... I think I see another bug, actually. Let me confirm that really quickly. Yeah, I think after we get past a certain point, I have a feeling that what's being used for the collision detection in the vertices is not getting updated. Yeah, because see, I can't click that right there. It's not until I come out here, which is like in line with the original vertices were, that I can actually raise that up. Which means, yeah, okay. So there's a couple problems with that. Okay. So let me test it in this direction. Yeah, it seems to be broken in both directions. Okay. Yeah, and see, I can't raise it past a certain point because the geometry becomes invalid as far as the detection goes. Let me see. Oh, I have some catch up to do on chat. Okay. Let me catch up here. I got a bit to scroll back. Yes, we are working on a terrain editor. This is a brand new terrain system that I coded over the weekend. And so we have a terrain painting already in place. So I can come in here and paint terrain with different materials and things like that. And so that's all well and good. I've got most of the bugs worked out of that. But now what I'm actually trying to work out is elevation painting, right? So that's something that we just started on tonight. So yeah, that's what we're working on at the moment. I think async IO is too much for chess specifically. Yes, I agree. Turn-based rather than slow-paced. Yeah. Yep. I would 100% agree. What if there are 800 players? I mean, for that you do need async. Yeah, but you're not going to have 800 players on the same board, right? So, I mean, yes, you'll need async, I guess, for packet sending and stuff like that, but it can be a really simple system. Yeah, I mean, your packets are going to be tiny for that. Let's see. So why C? Why not go with something like C++? So my C++ for years on end looked remarkably like C, right? I actually called it C++ Lite because it was just not... I didn't use most of the features of C++, right? OOP wasn't really something that I made heavy use of and things like that. And so I just decided when I started this project, I'm like, you know what? As a challenge, I'm going to try writing this engine in C. And I decided that I love the language a lot more than I thought I would. And so it just kind of stuck. That's why, right? So few technical benefits, right? Language simplicity. The compilation speed is hella fast. So at the moment, even if I do a completely clean rebuild, I'm probably pushing 100,000 lines of code at this point. Probably closer to 90. I'm not 100% sure. I can build the whole thing in 10 seconds, right? Whereas C++ would take a hell of a lot longer than that for each build. So, there's language simplicity, build speed, and like I said, I don't use most of the stuff that C++ offers anyways. Don't need it. So yeah, and C runs on everything, right? Not that C++ doesn't run on a bunch of stuff too, but there we go. C is a do-it-yourself lang. Let's see. I would agree with that. If you already have a library done for you, ArenaQ, your macros is very comfortable to work with. Yeah, so all of this stuff for this, I've stood up a library with all the utilities and stuff I need to actually build this application. So, it just kind of works because it was, because I've built up all those tools over time. Let's see. As a compiler designer, I can tell you not only is C standard very incomplete, unlike ASM, it's also quite difficult to optimize. Yes, there's lots of undefined behavior, but that is also true for C++. C++ as a language in general is far too complicated. It's gone in really hideous directions, and I'm not a fan, especially in later versions. Yeah, and as you mentioned, if you stick to a very small subset just above C, I did that for years. But then I'm like, why don't I just try working on C, right? Why don't I just try C? And so I did, and never looked back, frankly. Vulkan without C++ is outright unusable, for example. Nope, I have to disagree. I'm using Vulkan, and this is with C. So Yeah, this entire engine's written in C, and it's using Vulkan as my renderer. So I disagree. That's unusable. Diamond, good to see you. How have you been? C in debug mode is lightning fast. Yes. Almost transpiles to assembly. I would agree with that too. Yeah. Personally, I think operator overloads are evil. Yeah, so that's an example of a C++ feature I would use extremely sparingly. The only place that I kind of miss it is with math types, right? So your vector math, for example, having the, just being able to put the asterisks there to multiply them is nice, but it's not enough to make me switch to C++ for sure. I think what C++ has done for things like standard out and whatnot, with the operating or overloading the bit shift operator is just terrible, right? That's awful. A asterisk B compared to a dot mul B is not that much harder. A also star is just ambiguous in matrix. Yeah, exactly. I mean, it's not that much harder. It really isn't. Languages like Odin handle that by having native operators for those already built into language. Yeah, and I mean that would be great if I were, using something like that, but I don't know. Like it wasn't a big enough pain point for me to worry about it, right? All right. Oh, yeah, I should probably test this around water too. Yeah, that looks pretty good. I'm happy with that, right? Obviously, we need it to be able to back this off too, with negative heights and things like that. But yeah, cool. This is looking pretty good, I have to say. All right. So why are these breaks still happening? So I need to think about this. So what I really need to happen is, as I am raising this particular vertex, I need to also take this one with it. Which, strangely enough, I can't even select with the mouse because it doesn't seem to be recognizing the vertex updates. So I'm going to have to fix that too. Also, I may have to batch these into... Like, if I do a bunch of them, it takes a second, right? So that's not great. I wonder if I can do that in the middle of a frame and it'll be fine. Let me try that. Let me add that to the frame workload and see what it does. Because maybe that will just work. Rust is also annoying to write low-level performance code. Also, the compilation speed of it is kind of terrible. Let's see. So let's go here. Elevation. Doesn't seem to work at all, actually. That's interesting. Oh, I bet it pooped itself, didn't it? Yeah, it did. Okay. I wasn't thinking that was going to work. All right, so we'll have to optimize that later. Okay. So we know this change is good. So we can get rid of, we can get rid of that. Whoa, what happened? There we go. Okay. All right. So if we are at the end of the chunk, which would be index 8, right? Or x equals 8 in this case. Then we would need to do index plus 1 is not going to actually work. Now that I think about it. We need to do index plus... Actually, I think we can do... Is it going to be HF vertex count? Do I need a plus 1 on top of that? I'm not sure. Let's try it without first. I think I might actually have to add 1 to that as well, but we'll find out. So go here, elevation. Move this over a little bit so we can see. So let's see. That is 7. This is 8. Okay, so it doesn't look like it did the thing. 9. Oh, wait a minute. Zero 9. So 8 0 0 9. Am I thinking about this in the wrong axis? I think I might be. So 8 0. Is it going to be the plus 1 though? I don't think so. I think that's going to be still wrong, actually. We essentially need to take the index that we're at, we do, so x, is less than vertex count. So if x equals oh, does it need to be vertex count then maybe? Instead of quad count. Maybe it needs to be vertex stride. But no, because it's 0 indexed. So the vertex stride is going to be 9 based. No, it's not going to be that. So if we're moving along the x-axis, we want to move 1 chunk, not 16 chunks, which is what we'd have to do if we're moving the x and the z-axis. So that should be If we're at the end, we should move forward. Index. I don't think this is the answer, but let's see. Spiro, how's it going, buddy? Good to see you. Spiro, I don't know how long you've been here. I don't know if you've seen the terrain engine that I've been working on. But yeah, it's coming along nicely. Let me know if you've seen it, whether or not. So let me see. Let me edit elevation. So let's see, that's 5. Yeah, it's still got a break there. Oh, wait a minute. Am I off by 1? Because it was. It's raising that vertex with it.
You dingus.
So that's close to what I want. It's like 1 row off. Is that the +1 that I'm getting? Been lurking a while. Yeah, I appreciate that. Yeah, it's been crazy progress. Crazy visual progress. I've made lots of like behind the scenes progress for weeks now, but it's nice to see some visual stuff coming along. Absolutely cannot internalize oop like my brain breaks so that it ain't simple to me. Yeah, I mean, I've written a lot of oop, right? Over the years, I've written enough oop to understand why it's terrible. Okay, so if that's index was in... Why didn't this seem to work, though? Let me change this to 0 just for a second. Why didn't that seem to work when I had it +0? Unless there was something else moving that I wasn't aware of. Elevation. Yeah, it's moving that vertex all the way down there. I didn't notice that before. Okay. Let me think about this logically for a second. So if it's all the way down there, we've offset by an entire block, which actually makes sense as to why it's doing that. So instead of offsetting by an entire block, that's not what we want to do. We want to offset by a single row, not an entire block. Right? We're going to offset by a single row. So that's going to be the vertex stride. I feel like that's not right either. But let's try it. I feel like that's going to be too much. Actually, I'm pretty sure that's going to be wrong. I think that's just going to move the vertex in the same block, but like down a row. Pretty sure that's exactly what it's going to do, actually. Where did it... Oh, it's not even moving anything. Interesting. But why? But why, I say? Oh, it might need to be... It might need to be that. Offset an entire block, but minus a row. I'm probably going to have to like think about this offline for a bit, and the solution will come to me, I'm sure, if this isn't it. Okay. So that's 7. Yeah, it's still doing... Okay, minus 1 row. So that's not offsetting it in the direction that I want. Okay. So I think, yeah, this is probably where I'm going to wind up leaving off for the night. Because this is obviously not exactly what I want, but I think I'm going to have to take some time and critically think about this. Didn't I do... Actually, this might need to be HF vertex stride. Let me try that, actually. Last ditch effort. That'll give me the 1 unit offset that I might need. I think. Aha, it works. Okay, good. It works in that direction. That is what I needed. Okay, it's broken in the other direction. But this way it does work. Okay. So this needs to be probably the opposite of this, which I'm thinking is going to be plus HF chunk quad count. So that it should at least cover me between terrain chunks, modifying that. Let's see. Elevation. So here's the, that's 7, okay. 8, yeah, it takes both vertices with it. All right, now if I do it from the other side, it also does both vertices. Perfect. So we have the chunks working together now. So you modify one, you modify the other. Perfect. Okay. Awesome. That's actually a really good place to end, I think, for the night. So I do need to get this working in the other dimension now, right? Because obviously we can still tear the terrain this way. But that is pretty good. So I'm just going to leave myself a left off. Get this working along the Z axis. Okay, that is pretty much going to do it. By the way, for those of you on the Twitch side, if you are not following Spiro, you should definitely do it, because he's always doing interesting things on his channel. He goes over tech news, but he's also been working on a collection of different games on using the browser as his renderer. He does things such as using CSS 3D to render his game. He's also got another game that he's worked on where he's written the core of the engine in C, compiles it to WASM, and then uses the HTML DOM to render his game. So if you're not following him, you should definitely do it. He's always, got that kind of out of the box thinking going on in his channel. So Giga Chad stuff over on there. All right, let me just catch up on a couple of things here. Anthony over on the YouTube side is asking some really cool stuff. Does each chunk have a splat map? So I started off doing it that way, actually. But I realized as the terrain got larger in scope, that was a lot of splat maps, right? I think at one point I was creating over 1,000 of them, right? Just for 4 blocks of terrain, which include 256 chunks of terrain within those, right? And that's not like, that's the amount of terrain space that you were looking at there on the screen. And so what I did was, you have a terrain block, which includes 256 chunks. And so there's one splat map per block is the way that I have it set up. But yeah, it works pretty well, I think. I'm pretty happy with the way that turned out. All right, let me go ahead and find somebody to raid. And I see who I'm going to raid already. And I'm going to raid them before they raid me. So we're going to raid El's Dragoon. They're a team working on a Nintendo NES game using 6502 assembly. So we're going to go check them out. And yeah, if you guys haven't already, I would greatly appreciate a follow on the Twitch side and or a subscribe over on the YouTube side. Helps me grow the channel and all that stuff. I appreciate you guys, and I'll see you guys in the next one. See ya.